Hello again. Let's get into another lecture. So this time we'll be talking about the rectangular coordinate system, which is just a fancy way of saying graphing. And so we'll kind of jump right in. We're just going to talk about some properties of what a graph actually is, and we'll start off with some naming of some things. So let's go ahead and get here. So you've probably seen this before. We've got a graph here. There's a couple different parts on it. Very first things first, I should add this in. We have labels. Labels are huge. They're important. Without labels, you have no idea of knowing what actually your graph means. And those labels are going to be the y and the x right here. So those are my labels for each of the axes. I'll kind of jump around this list here. So the x-axis and the y-axis are given right here. We can see that from our labels. So the x-axis runs horizontally, the y-axis runs vertically. You don't have to use the letters x and y, but almost all the time you will, just because that's what mathematicians tend to do. That's kind of the common thing that we do, is we put x on the horizontal and y on the vertical. So there's labels for our axes. We also have the origin right here. Let's go ahead and put a point right there. The origin is the intersection of the axes. And so that just indicates that you're right there in the dead smack in the middle. And that's always where we're going to start off with. So we're going to start off at the origin whenever we have a point that we're trying to get to. And then we could do another thing. Let's say that I'm out here at this point. If we want to talk about where that point actually is, we could count -1, -2, -3, and that x coordinate would be equal to -3 right there. And the y coordinate we could count up would be 1 and then 2. So if we were to label this point, we would write -3, 2. We always like to label x and then y in that order. And so we'd label -3, -2, and that tells me exactly where I am. So you could probably guess here that I'd have 1 and 2 and 3 and so on there. And then if I go down on the y-axis, I have -1, -2, -3. And so this is kind of how we get around this this coordinate plane. We'll call this whole thing, we'll call it a coordinate plane. Last thing here, we've got some quadrants that we like to call them, and I'll kind of try and squeeze these in here. 2, 3, 4. So we've got 4 quadrants, and that just says which section of the Cartesian plane you're in. Which section of the rectangular coordinate plane are you in? Are we in this top right section up here? If so, then that's going to be quadrant 1. If we're in this section over here, that's quadrant 2. If we're in this section here, that's quadrant 3. And lastly, quadrant 4 right there. So just kind of a location thing there. And then something that can be a little weird is if you're actually on the axis or one of the axes, we just don't say that we're in any of the quadrants, because we're not in a single quadrant. We're kind of on the border of them, so we don't bother saying that we're in any of them. So there's the Cartesian plane, just a fancy name for everything we've got right there. So let's go ahead and practice plotting some points. I just did an example here. You'll notice that I basically have 2 and 3, and then I just make them positive and negative in all the different combinations. So let's start off with this in gray here. I'll go ahead and mark our tick marks. And a lot of times when you're dealing with a graph, and especially if you have this sort of grid in the background here that goes along, your tick marks generally, if you don't put any tick marks, it'll just mean that everything iterates by 1. I like to put the tick marks anyways and label them, just because it's a good habit to get into. But sometimes if you don't want your graph to be super cluttered, then you don't have to you don't have to bother doing that. You can just say, hey, yeah, all my tick marks are you know, they go by I'm counting by ones basically. So let's go ahead and do this. Let's go ahead and plot 2, 3 here in red. And so I'm going to go over 2, and then I'm going to go up 3. Remember that X, Y is that order. So I move horizontally first, and then I move vertically. And so I'm going to have this point right here, 2, 3. Let's do this guy in purple, 2, -3. So I'm going to go 2 over in the X, and then I'm going to go -3 down in the Y, and that's going to get me right there. So you can see I'm in quadrant 4 right there. Let's go ahead and orange, do -2, 3. So we're kind of getting the hang of this here. I'm going to go -2 and then 3 up. I'll get right there. And then last but not least, let's do this guy in pink. We're going to go -2, -3 down. So we'll end up right there. We've got our 4 points here. Just put that dot right there. Boom, we know that that's our point. And then you can label it if you want, but usually it's pretty clear based on your tick marks. All right. So we've got those right there. Let's continue on. So we saw before that we had these linear equations, and that's what we're going to spend most of our time actually graphing. But the question is, if I have a linear equation right here that I've solved for y, what does it actually mean to plot that? What does it actually mean to graph this y equals 2x plus 4? And as we've seen before, what we're doing is we're looking at pairs of x, y. So we're looking at x's and y's together, and we're trying to find those that make this equation true. Then once you have those, you just connect all of the points. So for example, there are some points here that satisfy this equation. If x is equal to 0 and y is equal to 4, then this equation is true. Another way of thinking about that is that if x is 0, then you just end up with 4 for y. And boom, there we go right there. And then we could continue on. You could say something like, if x is 3, then you're going to end up with 10 for y. And we could continue on. If x was -2, then 2 times -2, then we actually end up getting 0 for y. And so these are x's and y's connected together that give us our full point that works for this equation. And so when I have all those points, what we could do is we could just graph those points individually. We just did an example where we practiced plotting points. So let's go ahead and look at this. What I've done here, I'll highlight these in red. I've got these points here, and they're just these 3 points: 0, 4, 3, 10, and -2, 0. So we've got that 3, 10. We've got 0, 4, and we've got -2, 0. So there we go. Notice here that I actually have my tick marks be a little bit different. Here they count by ones, but going on the y-axis, they count by 2s. That's fine as long as you label it. If you don't label your tick marks here, then I'm just going to assume that they count by 1s. And you can assume the same of me as well. If I don't label the tick marks, just assume they count by 1. And so now we've got this right here where we have these 3 points. And so what we can do is we can just connect these in a line. And when we do that, we end up with this nice guy right here going all the way. Let's make that red. Well, we'll make it pink. Close enough there. And so we've got that. And now what's going on here with this line? We found these 3 points right here that satisfy the equation of this line, this y equals 2x plus 4. But what this line actually tells us is that there are actually a lot of other points that also work. And really, it's just any point that you could, anything that you could point to here. So if I went and I looked at this guy right here, that's going to be 2, 8, right? And that actually is going to work. And you could see this if I plug in 2, then I end up getting 8 for y. And that's good because we want every single point that's on this line. We want it to work for that equation. I could keep on picking points. I could pick -1, 2, and it'll work if I plug in -1 in for x. We're going to end up getting +2. And so there we go. We've got all of these points. And so that's the big thing with this line here, is that every single point on this line, all of these, they all work and satisfy that equation that we have. And they keep going on forever, right? I could use really, really large numbers or really, really, really negative numbers, and it would still work out. And so that's kind of the basics of graphing a line. When you have a line, when you have I should say a linear equation right here, you're just going to find some points that satisfy it. Pick a couple points and graph those points. And once you have that, just connect them on it with a straight line there, and a ruler could help you out a lot right there. And so that's actually just the basics of plotting linear equations. Later, we'll get more into how to do this sort of in a faster way. We won't bother, sort of plugging and chugging and just picking a bunch of points that work. We'll actually look at things like slope. We'll look at things like a y-intercept. We'll see some other faster ways to do this. But for now, we'll just focus on plotting points and then connecting those points to make a line. So we'll go ahead and call that the lecture right there, and it'll be on our way.